Welcome everyone back to this morning, the rest of this morning program of the IUBC School on Astrostatistics and Machine Learning. So for this morning, we will continue on with the session of the problem solving with astronomical data, particularly on classifications. We have Dr. Anirut Phriksee with us today. So for this morning and then continue on this afternoon, Dr. Anirut Phriksee has received his PhD, a dual PhD degree from Chiang Mai University and at Marseille University from France, while receiving as a receiver Thai scholarship. His main research topic is on cosmology, particularly on the weak Gaussian lensing. He's currently a postdoc at NARIT, working together with a group of cosmology and high energy astrophysics science group since last year after he received his PhD. And his expertise is very much in the way of observational cosmology, particularly on the complex data analysis, okay, and modeling. Okay, so here with us, I'll give you Anirut, so you have the floor. The session will go on until around 12:15. The format is that during the tutorial, the participants can raise their hands to pose questions here, or can also have their question posed, and then we try to address. Okay, without the way.
Okay, thank you, Dr. Uten, for the introduction. Today we go with the hand-on of the the problem solving with the astronomical data in the topic of the classification. For the topic in the morning, we separate into section. In the morning section, learn how to retrain the classifier. I select the 5 classification. First one, a logistic regression, stochastic gradient, support vector machine, k-nearest neighbor, and random forest. Learn 5 classifiers. We have time to go a little bit in the neural network and how to see how you use the machine learning to do something with to solve some astronomical data. Okay, for the coding, I'm not sure everyone know about the Jupyter or Google. If you don't have the Jupyter notebook on your computer, you can use the package. For example, I suggest the Anaconda. You go to Anaconda.com and product individual here, and you can download from the site. Support the Mac, Linux, and Windows. Why using this? Because they contain a bunch of the software that already pre-installed for the Python, Jupyter, SciPy, Spider, NumPy, and the Jupyter that we can use today. And the TensorFlow that used for the machine learning, Matplotlib for the when you plot something that is quite nice for using in the Python. So if you don't have, you can try to install this. But if you when you install the Anaconda, you can launch the Anaconda navigator like this, and you can launch the Jupyter notebook from this program. For example, you launch here, and you open the your web browser, and you can coding through the web browser like a Google Colab. I think everyone know. But if you don't know, you can try to use this. For example, you new and country, for example, and we will show the new one, and you can coding here, and and you can run through the web browser. But if you don't need to install the Jupyter Notebook, for this section you can use the Google Colab. The Google Colab, I think you already learned in the previous section. You can use from the website. I will show you in some that I think I'm not sure you when you click create the notebook from the Google Colab. Okay, wait a second. Okay, let's see in the detail. This is like a Jupyter Notebook, but it can connect to the Google Computer Engine. That's why we can run our program via the Google Cloud Computing. So that is fine. Don't use our resource or our computer, and you can share the our notebook if you need to send for some project in the afternoon. So that's very useful for collaboration in the research. Okay, see in detail, you can run the code in the cell here, simple you book, but specific in detail that I would like to go to and can I just okay, click the runtime, change the runtime. From the runtime, you can select the none is use the CPU hardware, and you can try to use the GPU hardware. That is quite accelerate your code when you try to use the machine GPU hardware. That's why you can select the notebook setting here. Okay, another one, you go to set, can okay, change the theme on side. And if you need to run the free version of the Google Colab, if you need to run longer, for example, run longer than the 1 hour, you can go to Colab Pro. They have something quite pity. You can go click this one, and okay, you can see the the dog in the chat bar. So that's it. Okay, back to our work. For the data of this section, and in the afternoon, you can go to the website, or you can in the Google Drive. We have the data. In the morning, we will work with the star galaxy classification. We will try to separate the star galaxy. In the afternoon, in the section that you need to do in the project about the galaxy quasar classification, and for the neural network, we will try to estimate the redshift by using. Okay, and the notebook, you can go to this website. I already prepared. Okay, back to the classification. Each step in building the program or the model is just like we can separate roughly in 4 steps. The first step about the prepare, you need to prepare your data. What is the data that you need to input, and what is the data that you need to, and in the data, you need to split them into the test and the train data. I will talk in the next slide why we split, because in the case of we need to classification model, we don't use the test data to find the accuracy, but we use the test data, that random draw from the raw data to evaluate the accuracy or the model that we already trained. Okay, the step is first we prepare the data, and then we train the data, and from the data we use the model to predict, and then we evaluate with the real data that we have. Okay, this is a step that, but when we go in the detail, we can see how the program works in to build a program. Okay. Start from the preparation of the data. From the raw data that we already have, we need to split them into two groups. The group one is the train data. We use the train data to train the model or train the classifier, and split the few percent, maybe 20, we can test what is best, what is the best fraction for the test side of the data that we can try to find the accuracy. Okay, the train data we use for the train the classifier, and test data we need to find the accuracy of the of our classifier that we already trained. Okay, and then when we already train the model show in the, for example, we have the model in the yellow box. We use the test data because the test data is random draw from the raw data, so it's not trained in the model. We use the test data and use the model that we already trained to predict the prediction, predict the result, and then we evaluate the result with the real result that we already know for the test data. The evaluate between the prediction and the result, we can find the accuracy in the program. Okay, we problem solving with astronomical data. The first job that we need to do is about the star galaxy classification. The simple question: how we separate star and galaxy? You have any idea how we can separate star galaxy? For example, this is an observed image from the SGS DR9, DR16. How we separate the star and galaxy? Okay, you maybe sometimes you can, okay, we can see the object like this is elliptical. It should be the galaxy. The circle, it should circular. The point, it should be the star. But sometimes it should be galaxy. How we separate them? In general, we use the software to extract the object between the star and galaxy, because the light distribution, when we measure the light distribution in the object, the point space function or the half light radius or the full width of half maximum of the star and galaxy has different. So we can use the, for example, in the show the data from the KISS survey. In the right hand side of the picture, you can see in the x-axis the signal to noise, and in the y-axis is the full width and half maximum or the half light radius. So you can see that the star is has some specific of the full width and half maximum shown in the red, and we can find the signal to noise of the star is quite high, so that we can try to separate the star and galaxy using the half light radius, full width and half maximum, and the software try to extract, for example, like a sort attractor. Sort attraction, so that is why we can separate star and galaxy. But in this project in the morning, we will try to use only the magnitude. If we only observe the star on the sky, how we can separate star and galaxy using the magnitude? Okay, go to the data that we use the data from the SDSS DR9. You can access via this link. Okay, you can click here. Okay, and you click, you see this section, data access, and go to SQL search here. In the SQL search, you can fill the form that is specific that you need to queue in detail. For example, if you need to select the, for example, 100,000 object in the top of the this database, you can click like this. Can I zoom in? Okay, we try to select the 100,000 object in this database, and the column, it should be ID, RA, DEX, and this is show the magnitude in UGRIC band, in the 5 band, and these are specific detail for the spectroscopic data. And we can specify the unit, the magnitude. For example, if we need the magnitude U between 0 to the 19.6, we can assign like this, G between 0 to 20. And then you, from the output format, I suggest to use the fit file because it's quite general to use, and throughout this section in the morning and in the afternoon, we work with the fit file. So you click the fit file and do submit the query here, and you will you can download the catalog that I already download for you. You can access via this link. Okay, back to the slide. Okay, did show the website. Okay, and when we when we look in detail, you can see we have this column. The first one that should be the RA, that we need to see the distribution of the object RA and DEC, and we have the magnitude in 5-band filter U, G, R, I, and C, and the class that already defined as the star or galaxy, and the redshift. In this work, we use only the magnitude and class in order to classify the star galaxy. We do go redshift because you know that the star is near us, so you can easily use the redshift to classify star and galaxy. So no, in this case, we will use only the magnitude and class to classify. Okay, this leads us to the job one. I think everyone to do this. The first job, I give you the 15 minutes. You to job using up to you to Python notebook or the Google Colab. The job one is you need to import and visualize the data using the feed file from the feed file format. First one, the first job A is import the data from the catalog file. I suggest to using the AstroPy attention, and B, create the parameter for each column and data set. You can see you need to assign the column U, add the U parameter. For example, G, add the G parameter. So that you can try to assign or create the parameter RA, DEC, U, G, R, I, and C, and class of the object. And then class, the class parameter you see in this table, the class is galaxy or star. Sorry. You need to assign, create a new parameter, for example, objective class parameter, and you assign the star equal to 0 and galaxy equal to 1, okay? And then you plot this relation. You need to plot the position. For example, you just simple use the Cartesian coordinates, x, y, so plot the position RA and G, R, C. But the question is, the problem is, you need to separate the star and galaxy in the plot. I will show you later. You need to, for example, if you plot the histogram of the U band, you need to separate, okay, the star, U band, galaxy. Next, see the relation of the magnitude. For example, you plot U vs G, G vs R, and SI and I vs C. You plot the magnitude between the, and then same. You plot the scatter and you separate the star and galaxy. For all detail, you can go to this link. For example, for the feed file open, the matplotlist histogram here, and the scatter plot in this link. And to go, if you see this icon here in the PowerPoint, you can click, hold the control and click. It will open the Google Colab for this job. Okay, I already prepare for you, but you need to do something in the code, or you can copy in your Google Drive and then you coding, continue coding in detail. Okay, first, for example of the import data, you can download the data. I already put in the Google Drive. That is the file name is SDSS star and galaxy. You can use the AstroPy fit, or you want to use another one, that up to you. You can use the extension that you want. I just show that we can use the, and okay, you open the file of the fit file, and then handle with the data you use to call the data from the fit header here, and then you have the data here. And if you want to assign the data, you need to go to specific column, for example, IA. Okay, I will show you in detail first. Okay, we go to the visualization. Okay, To the first one, we need to import the extension first. We import 3 extension. The first one, the second one is a matplotlib, and the last one is a fit file that we need to open the fit file. Okay, you can, when you connect to the Google engine. Okay, after connected, you can see the RAM and the disk. It show you have the 12 gigabyte of RAM and around 70 gigabyte of disk for working. Okay, when you need to run this cell, you can click here. Okay, if everything fine, show it and show the execution time here. And the next one, we need to import the data. I use this link that I already upload. You can copy this and use this link. It takes up time, but sometimes if they already the cache file, that's quite quickly. You can see it's just already download the data here. And for the data, we can from the handling here, you can check the header by typing it. To see the header of the fit file, you can try this. Okay, and it will show you the detail of the column of the fit file. You can see this is show the first column, what is the column name and the type, the formats of the column. RA UGRIC, and the last one that we would like to use class here. Okay, you can use the header like this. Okay, for the data you use to sorry, it's going to okay, you use this one to assign the data from the fit file to this. And if you would like to assign the RA, go this, the data RA, because it is the name of column, you can check. You need to and like this. Okay, for the object it's same. Okay, and you create this parameter and try to assign the class star equal to 0 and galaxy equal to 1, and then plot the relation, histogram, and magnitude. Okay, I give you 15 minutes and you can do this example. For example, this show the pause A and Dex. This show the position part, this relation of the magnitude U and G. You can see I separate the star in the red dot and galaxy show in the blue dot. This show the histogram separate between the star and galaxy. Orange is a star, is a galaxy, and the blue histogram is a star. So now is 11:10. I give you 15 minutes, and we back to please type first about this job, because in the after you will do this again. So okay, let's coding.
to the participants. If you have any problems, feel free to either post your questions on the chat or via the okay. Day 9 has been created. Invited to that channel.
can finish. If not, you can go to code together with me. Okay, please to my video. So okay, we go together. For the job one, we need to visualize the data from the feed file. Okay, I already show you import the data, and then import the data from the feed file that you can access via the website, or you can use only the if you already download. Okay, and next to create the parameter in the section, create the parameter for each column and data sets, RA, DEC, UG, IC, and class. You can use this code. Okay, RA, you assign the data, the column RA. DEC, you assign the column DEC. For the object class, input object class, you can see you use the data class. You can see the class, the object class is string strings parameter. See star galaxy. Try to assign the class parameter object class here. If the star, it should be 0. If galaxy, we assign as 1. In the next section, assign the class parameter star and galaxy. You can do anything. For the example, first we create the blank parameter. To create the blank parameter, we need to know the number of the object first. To find the object, you can use for example, use the length of parameter. You use this function, and n is the number of object. Okay, you can print here. Have the number of object in this catalog. Allow the 1,000 object, and then we create the empty parameter here. For example, parameter with the number of the object. Okay, and you can use the simple thing, use the for loop. I try to code in the simple. You try to check in each object class. If the star, you the object class, the new parameter as 0. If the galaxy, you assign is the 1. So you can use the for and if. For example, input. If the input of the object here, okay, object class in the object A, okay, before J in the 0 to the number of the object. Okay, if the object J equal to star, we assign the object class here J equal to 0. You can use another method. I use the simple one. Okay, if the object class is the galaxy, the object class should be 1. Okay, and you can add the L here. For example, if you have another one, sorry. Another one, if not star or galaxy, you can try to error. Okay, and pin the J here. Okay, and then you run this command. Finish very fast. Okay, you can try to check. We input this from the catalog. You can try to pin only, for example, the 10, the first 10 object, and then we will compare with the object class that we already seeing the simple thing here, simple code here. Okay, just check that everything fine. Okay, you can see from the input you have the star here, and the new parameter object class at the 0. Okay, galaxy and star, and okay, 0, 0, 0, 0, and the last two galaxy and galaxy number 1, 1, 1. Okay, this fine. So that we can assign the object class, and you can use this code afternoon later in the project. Okay, go to the part this relation. Okay, The first one is simple. You need to plot position. You can use the pie plot that I already take here, and this is you can use the symbol here. For example, you use the dot, you can use the Y, or you can use the O like a circle symbol, like the cross symbol, or the top hat. You can use many symbol here, but I prefer use the point and in the color. You can choose the color. For example, the red, you can use the red, green, but in this case the black. And if you plot the object, many object in field, you need to the change the marker size or the size of how to change. You can use this one, marker size go to 0. Then you plot like in order to have a nice plot, you can add, for example, the label in the x label. If you know, just skip in detail. So, but if you don't know, you just we just try to work together first. Okay. It's dex and I. Okay. This show the x parameter that you assign here, and the y in the y-axis. Okay, that's why if you need to plot, you can x as RA, y as declination. Okay, and you try to run. We show you RA and x here. If you need to set use this function save figure here. Try the number name file. For example, you need to export PNG to this PNG, and DPI is a resolution. Actually, generally we use the 300. Okay, and then here. Okay, and you can access the save figure here. You can see. Yeah, this is a figure that you can use for presentation or anything. Okay. Okay, back to the histogram. Okay, for the histogram, I think I will have a little bit problem how to separate star and galaxy. I have a trick that you can use in order to select between the star and galaxy that to plot, because we need to plot the histogram that separates star and galaxy. So we need to create the condition first. How the condition works. So if we need to select star, we create parameter that condition the star, the object class should equal to 0. You just assign the condition here. If we select the card equal to 0, and if you print out this one is the default parameter, you can see the object class of the object one is the array of the select star is true. So we do the same with the galaxy. For the galaxy object class 1. Okay, and then we can go to plot the histogram. How to plot the histogram? It's quite simple. You plot like this, histogram, and you assign the parameter. The first one that we try to plot is the can I check the magnitude in U. Okay, you need to plot the U magnitude. We plot all the object first, and then you plot show here. Okay, and okay, this show the distribution of the U magnitude. You can add the label here. Okay, and in the y-axis, count all the number of object. Okay. Okay. But if we need to start, the trick is we can assign the selection here. Okay, you add a bracket and you use the condition here, select star. Okay, detail, for example, equal star, and histogram type equal to, you can find the detail in the website that I already show in the presentation. Okay, for the star, we add the label as star and histogram and like a step. Okay, the same, this is for the galaxy. Okay, histogram types. Okay, and we can plot here. Okay, we add a little bit of the legend. The legend here. The legend is the red show the detail of this in our galaxy. Okay, you plot first. Okay, you can see this show the star and galaxy show in the orange. And if you need to location is you can use this one LOC equal to the number of the quadrant, the second quadrant, third quadrant, and the fourth quadrant. Okay. If you need the its position is a quadrant 3, you assign 3. Okay, it's in the position. Okay, but if you need this, just like this. Okay, and you do the same with the GRIC. Okay, you access this collab later. I will prepare everything for you, so you can access that. Just show the how you can plot histogram of the star and galaxy. Okay, we next you do with the GRINC. Okay, and next plot the scalar magnitude, plot the USG, USR, and IVC. The same with separating star and galaxy. Okay, the same. Use the plot like this because we need to the scatter plot in U and G. Okay, assign acid and G as a y-axis. Plot the scatter plot. Okay, need to change the color again. X is 2 and Y is G. Okay, try to plot. Okay, this you can see this is a scatter plot of the magnitude in U and G band. And if we would like to separate them, okay, you can use the condition here. Use this one. The same, you to put this one. This is for the star. Okay, add the label. Okay, and for Phriksee. A little bit indicate that I want you to understand, because in the when you will repeat work again. Okay. See. Okay, move on. Okay, you can see I caption. Okay, see the left and book can probably as separate the magnitude band, but not clearly because we have lab in the. But in this, you can see the star quite split out from the galaxy. So that's why the magnitude can use. So you can try to plot for the SRI and IVS. So, but you using this you need to add the condition to port for the simple like you to use just create the select the condition first. If you need check card equal to 0, select card equal to, okay. Yeah, I think you can try in Slack. So I think we can continue in the next shop. Buyer. Okay, back to the. Okay, now we already input the data to file that we can magnitude to define the galaxy. So to work with the data, the classifier I show for exploration. The first thing that you need to do is you need to the many parameter for you stack in yellow. I stack UG IC magnitude. So object magnitude, you see the first is a U, the second column is a and we can parameter because it's to use in the data. Okay, first use the input in this case magnitude. Okay, we need to split the data because I told you we need to test, and for the we use the data train classifier and use the test data to find the of your model. So that's why we split train data. Easy way to use the from the scikit. You can use this called the scikit-learn scikit model selection. Use the test split and train test. You use the code the x10 x test y10 y test and test split and parameter object magnitude that we already stack in 5 band. You put here card that you can win the star. The test size is the fraction of the data that you need to 0.1%. Okay, you use the it is we select 10% of data random draw from data to test the accuracy. So that you can see in the train magnitude for the train data is the magnitude that we use higher. Y10 is object card for and y is the result unify or compare prediction when you use the of the x. Okay, x10 and y10 classifier. X and y test we use for to find go next to the train data. This show the for the logistication. You can use the sklearn to import the detail of the logistic regression, and then you apply the model LR equal the logistication function import. In parentheses, you can add many detail. I skip this, but you can do the website. See, they have many parameters add in this to group the we train the application by x10 is a magnitude input and 10 it should be star or galaxy. Okay, train the and then we use this model to predict the x test. Okay, the x is the test data we already draw from. Okay, you use the x here, you model that read weird line, and you model to predict the x test, predict the x will give y prediction. And some of the prediction here of the model you can find accuracy y test because test is a result from the that we are. Okay, try to understand it. Okay, and find the accuracy. Use the simple model you in mathematics. You already read the document in the previous section, but can we use those to check the accuracy of the classifier model? You can use the this one is from the scalar matrix score, and the accuracy score is 5 over the of the sample summation of the y if y and y equal to is similar. If the y to y prediction should be 1. If it is not equal to y, that's why is in the length 0 to 1, and if you have the one, that's the accuracy of the quite good. If the this one, for example, you import this and you use the accuracy here and input the y test that you split the real data and y prediction that you from the model already 10 here, second step here. Okay, you will get the here. Okay, that leads to up to a big complex in the detail. So let's try to get. No, you can try, and I will show you later. The 25 to do this have some. You need to equal to 0.1. You take y classifier, logistic regression, stochastic support vector machine, neighbor, random forest, and B, you evaluate the result is algorithm using find the accuracy. And then you A and B by setting the you change the test size 0.2, 0.3, and you what happens if you change the test 0.2 and 0.3. You can go to the code here. You can click Control and hold click here. Okay. This is an example you to do. First, the data, use the same data. You parameter, you use previous code. Split and take. I already show you use how to here. Split the data using this code. Okay, and then you can the classifier, fixed test size 0.1, and then you evaluate of accurate in each algorithm. The test size to 0.3, and then you can compare the accuracy in each process. Okay, I already give you the for that you can use in this job. Okay, for logistics, so you can use this one. Stochastic gradient, you use SQL model and in the plan it's just add some but you can go to site, for example. Okay, show in the you can change loss function, the max iteration, everything that you can try. But now just try to add in this. Okay, and then you can fit stochastic. Either you fit the x and y tail. Okay, neighbor. Okay, this one import from scalar neighbor. Import this one and change the number of neighbor here. I set the 10. You can try to 20 when if you change. You can try later. For the support vector method, it use the same kernel linear C equal to random. Change the C here. And from storage using this one. Okay, and you can try to fit the file classifier. I give you I think 20 minutes. We together for the data set. So let's try first. We go there.
I'm sorry, Upen. There's a question in the Zoom chat.
Okay. So Anirut, you want to take that? There's a question on the.
Okay.
Yeah.
I think I already told you the UGRINC is a magnitude of the object in the UGRINC band filter that is taken from, if you see this, is a magnitude, UGRINC, absolute magnitude of the in each object. So we use the magnitude in each object to try to classify the galaxy. We do not use the redshift or RADX, just use only the magnitude and the cast parameter. Okay, and I think we only have the 5 minutes left, and I will show you in detail, and you can continue work later. Okay, back to my screen, please. For the job 2, it is about the classifier. We try to train the classifier, file classifier. Okay, the first one is you need to import the data. To import the data, use the similar of the previous job. You import the data file, use this catalog, star and galaxy, SDSS, open the data here. And from the data, you assign parameter in each column, RA, DEX, UGI, and C is a magnitude in UGI and C band filter from the observed data. In the object class, star and galaxy here, we print the number of the object similar with the previous job. So assign if the object class is star parameter, object class should be 0. If the object class galaxy, we assign object class to 1. So we have the object class star 0, object class galaxy 1. And then we stack magnitude. Same with my slide here. First, we need to test data by parameter. The input in this case, we use the magnitude. We input the magnitude here. You see, the input, and the parameter that we need to know is object is star galaxy, and in the you can check the my slide again. So okay, we split the data to 10 and test data set. The test size is a fraction. If 0.1 is a 10%, 0.2 20% of the test data used for to evaluate the the classifier. So we have everything. Then we need to train the classifier. The logistic regression. Okay, we go together. The logistic regression, I already give you the code. You can copy this from this one. Okay, you copy this. Okay, in detail, we call the function of the logistic regression function from the scikit-learn tool here. It's a linear model here. And then we create the model using this one. We create like LR. LR is a model that for the logistic regression. And then we train the model using this line. We train x10 and y10. X10 is a magnitude. Y10 is the class of the object star or galaxy 0 or 1. Okay, and then when we finish the 10 here, we predict the y predict of the test data. The test data that we split for the evaluate the model, we put here and we create the y prediction here. Okay, you can try to run this one. Okay, finish. This is a y prediction. We add a little bit subscription here for, wait a second, for the logistic regression step size 0.1 here, like this. Okay, and then when you need to find the accuracy, I just show the only the one simple. Okay, for accuracy, how to do that. Go back to slide. You can use this one to find the accuracy score. Okay. Put here. Subscription test size 0.1. Okay, like this. Okay, what we do here? We will find the accuracy. The y test is the class of the object that we know from the input data here. The y test is a class, and the y prediction is the object class that predict from the logistic regression here. Okay, a little bit change. I will put here. Okay, and then we will print the accuracy score. The accuracy score is between 0 to 1. If the nearly 1 is the accuracy very high because they can predict, they can classify. Okay, let's try to see what happened if we use the test size 0 to 1. You can see the accuracy is 0.92 and nearly 0.93. Yeah, it's quite good to estimate the file the and go to the another gradient using this one. I will show you only one and can tie with the test size 0.2 and 0.3. Okay, for the stochastic gradient, you're using this one. Similar and sorry. Okay, just change to, for example, HGD for the y stochastic gradient. Okay, use this one from this slide. Just okay, like this, and you run again. Okay, finished. And for the k-nearest neighbor, you do the same. Just using this one, and to train the data, you need to fit here x10 and y10 here. Okay, and then you predict the for the test data. Okay, this you see this SCD and KNN fit is a KNN is a model of KNN. Okay, never classify it here. Okay, and you can get the validation to find the accuracy. And the last one is random forest. I skip something. Okay. Okay. Do the same. IFC. Okay. Take a time for you can see you have the similar first you import the model logistic SCD can neighbor random forest, and then you fit the 10 and the x10 and y10. X10 is the magnitude, and y10 is a class of the object, star, or galaxy. And then you use the x-state to predict the y prediction, to predict the class of the x-state, and then you find the accuracy here. That is you can evaluate the accuracy in each algorithm. You can try to do more in the test size for 0.3, 0.2, and 0.3, and you can compare. I have the I already did it. I will show you in detail. Just a few, just one. Okay. Okay, this is similar, but I already learned. You need to do the file classifier, and then you evaluate in each algorithm. You can see the accuracy, and then you change the test size to 0.2 here, and then you do again, repeat again, change the test size 0.3, and do again. Then this show the result when you compare accuracy. You can see when you change the step size, it's not changed so much in the accuracy because of the data. We have a lot of the data in our analysis. So, but it's something that you can see that the random forest is quite good, 0.96 in this algorithm. I will put the code here, and you can check again later after the afternoon. Okay, in order to summarize in the morning, okay, we back to slide. Okay, how we choosing the algorithm for the classification. So this is show the flow chart. You start here. If your sample less than 50, okay, you cannot do anything. Get more data. Okay, predict the category. Yes, in our case, you have the label data. Yes, you go to this one for the classification. For the classification, if you have the less than 100,000 sample, you go this one. For the HGD classification. It's not working, you go to the kernel approximation. This is, and if you have less than 100,000, you go to linear. Not working, take data or not. If not the take data, you go to k-neighbor classification, or it's not working, you go to the SVC, ensemble classifier. So that is a summary of the classifier algorithm, and I think you can try to learn more in detail how to use in the specific. For example, if you can add the function. Yeah, for example of the logistic regression, you can see they have many parameters that you can set, and I think you already learned in the previous section. You can set every parameter, for example, penalty, tolerance, and the C factor. So you can try to change every parameter here. Okay, and I will put the complete code. You can access via this link later in a few minutes, so you can check again. And in the afternoon, we will back together to do the job. In the afternoon, we do the same, but you need to send the project here to me. The job that you need to do is about we try to separate, classify galaxy and quasar.
Since we already kind of like run a bit over time, so maybe we just keep the explanation on the afternoon part till later.
Sure. Just a little bit.
Yeah, there's also one question from the participants regarding the notebook at the beginning. So the person who asked the question, would you like to elaborate a bit more on which on the notebook which part of the notebook you said at the top, but exactly on which point? Subhan, is it?
Yeah.
So
Hello.
Could you turn on your video microphone and please?
Yes, sir. Hello, sir. Am I audible?
Yes. Yep, we can hear you.
Am I audible?
Yes.
So actually, I was just asking, like, oh, you just opened the FIDS file with fids.open, so and then you read the data with .data, so we can do this, like we can also convert it to pandas, like we can read the FIDS file from pandas as well, right?
Sure. You can use another one, but actually I prefer the AstroPy because the AstroPy package contains another package that you can use for the future work, for future research. For example, you can use change the coordinate system, change the units, and conversion, everything that you can do with the AstroPy. You can use the Panda, but I'm not sure they can work with the FIT file. Or you can import the FIT file first, and then for the data here, you put to the Panda structure table, and then you can work similar. That's the same. It's up to you. If it's not stick, you can change. But it's when I try to do this, it just make a simple thing. Use the numpy parameter. You x here, assign the parameter magnitude here. That's just a simple one. Yeah, you can use the pandas. It's okay,
and I was
and I
asking,
think
like, because when we open fits.open, so reading the fits file in a table format, right, or not, like, because in pandas we can create the data in the table format.
yeah. If you want to use it, I can try to create another one, but the question is why you prefer to use pandas.
No. I was asking, like, by reading the fits file with fits.open, so this fits reads the data in table format or just like normal
And
The data, right? So it's
yes, it's
it's in
not in the fit file. It is the image or the table, but in this case, we use in the table format. We fit file used in the why I try to use fit file, but in this case, it's the table, not the okay. Like
Thank you.
you the table.
in this case
Okay.
with units, and so in fit file sometimes also in this metadata which explain or kind of like encapsulate what different columns of the table is, and then that kind of have other inherent like units and so on. Okay. So right, the end for the morning session. We with all time. We will return.
Yeah, sorry, 10 minutes late.
Okay. Okay, hand this back to our organizer. So do we still starting at or should we delay the starting time a bit?
We can start at 1 o'clock.
Okay.
Is it okay with 1 o'clock?
Yeah, it's fine. So
meet back here.
Uh,
in rough,